Welcome, ladies and gentlemen, to this video lecture. Okay, so now we move on to our next form of integral that we want to be able to compute, and this is when we have a product of tan and sec. Okay, so we want to be able to compute an integral of this form. And the first thing that we should notice is, or that we should remember, is what is the derivative of tan and what is the derivative of sec. So derivative of tan, that is sec squared, and the derivative of sec is sec x tan x. And just for good measure, this doesn't hold everywhere. This is when x is not equal to pi over 2 plus k pi, where k is an integer. You can think of why that is. That is because the tan and the sec functions have singularities at these values. Okay, so here we've got our derivatives. And now we want to consider integrals of this form where the power of tan is odd. So consider the following. Consider for n and m natural numbers, and consider the following expression. I'm going to write it over here. Tan of 2n plus 1, so that is odd, multiplied with sec x to the power n. And the idea here is now we want to what do we want? We want remember here, the derivative of sec x is sec x tan x. So actually what we want here is we want some polynomial expression in sec multiplied with a sec x tan x. So some polynomial expression here in sec x multiplied with that. That is what we are looking for. Okay, and we can immediately see how we can get there if we use the identity, use the trig identity. We use the identity tan squared x plus 1 is equal to sec squared x. So we can, using this identity, convert tans into secs. Okay, so what will we do here? Let us take out one of these secs and one of these tans, and let's write it like so. So tan 2n x sec m minus 1 x and sec x tan x. Actually, don't have a lot of space there. Sec x tan x. And we see here we've got the derivative of sec x. And now the idea here is to convert these tans into secs. Let us write this in, instead of writing it there, write it over there, and now we will use this identity that we have written down there. So what do we get? This part is equal to sec squared x minus 1 all to the power n sec m minus 1 x multiplied with sec x tan x. And here we see we have a polynomial expression in sec x multiplied with the derivative of sec x. And remember, that will give us, now we are in a position to apply the chain rule in reverse, so the derivative chain rule in reverse. So that is the idea. Okay, let us put this into practice with an example. Example. We want to compute the following integral. Integral from 0 to pi over 4 sec cubed x tan to the 5 x dx. And we see here we have an odd power of 10. So we are in the situation that we have just discussed. So let us rewrite our integrand into a form that we can actually integrate. So sec cubed tan to the 5x. Let's take out a sec and a tan. So that becomes sec squared x tan to the 4x multiplied with sec x tan x. Okay, let's put some brackets there. Let us write this tan as tan squared squared, and let us use our identity that we have here, tan squared plus 1 equal to sec squared x, to convert these tans into secs. So this is sec squared x, and this then becomes, what does it become? Take it across, sec squared minus 1. So sec squared x minus 1 all squared multiplied with sec x tan x. Okay. And now let us multiply out this factor in terms of that we have expressed in terms of sec. So that is sec squared x multiplied with sec to the 4x plus 1 minus 2 sec squared x multiplied with sec x tan x, and let us multiply this factor in, so we get sec to the 6x minus 2 sec to the 4x plus sec squared x multiplied with the derivative of sec, which is sec x tan x. Okay, and now we are in a position to compute our integral. So our integral is integral from 0 to pi over 4 sec to the 6x minus 2 sec to the 4x plus sec squared x and multiplied with derivative of sec x tan x all dx. Okay, so this then becomes sec to the 7x 1 over 7 from that term minus 2 sec to the 5x over 2, no, over 5, sorry, over 5 plus sec to the 3 1 over 3 sec x. And if you see, if you pay close attention, if you now take the derivative of this expression, you will get exactly the integrand there. And this we want to evaluate between the bounds 0 and pi over 4. So from 0 to pi over 4. And if I did not make a mistake in my calculation, this ends up being 22 square root 2 minus 8 over 105. So that I will leave as an exercise. Okay, so here we have seen an example where we have an odd power of tan in our integrand, which consists of sec and tan. Okay, I will see you in the next one.